Now. Hi, fifth graders. Mrs. Moore here today in room 205. We are going to be working on lesson 3.3, which is about estimating products. We're going to sneak a little bit into some sixth grade content today. I'm going to show you a trick that revolves around decimal factors. And so we're going to need a couple of different tools. Pencil, obviously. Highlighter would be nice. And maybe a different colored writing tool so that when we're rounding, we can call attention to the place value that we're rounding to, okay? So have those things on hand, and the first thing that I guess you should be open to in your resource notebook is gonna be those multiplication tables. So this is the part of the lesson where you're gonna sit back and listen. This is the mini lesson chunk. This is the part where I push some instruction, and then we do some guided practice together in your workbook. And then you go on into some independent practice. That means on your own. Usually we call it homework, but that's kind of how a math class is organized. So the kids in the classroom here are eating snack. We usually do a one-sentence prayer to start our class. And it's, here, I'll pop it up on the screen in case these people at home haven't seen it in a while. Let's see. Oh, just passed it. There we go. All right, everyone, if you'd like to join us in the name of the Father and of the Son and of the Holy Spirit, amen. Simply, Jesus bless us and center us this day. Amen. In the name of the Father and of the Son and the Holy Spirit, amen. And how about we do our 4 times tables today? Okay, ready? 4, 8, 12. Are you looking at your paper here? Find the 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68. Can you keep going? It follows the same sequence, right? 4, 8, then a 2, then a 6, then a 0, then a 4, then an 8, and it keeps on cycling on the digit of that last number, right? So today, and I stop sharing here so that my class can see, you guys can see my Promethean board all right, correct? You can see where it says estimate products. Yep, all right. Now this is a page actually from your textbook, and we don't have to open to it right now. I'm just letting you know where it's from. It's on section 3.3, and we're going to talk about estimating a little bit more. Now, we talked about estimating when we were covering something called rounding. Do you remember that? Rounding? So another word for estimate, maybe if you want to kind of put it over here underneath it in your mind, is called rounding. And we learned how to round or estimate to different place values. We would say, okay, for this one, I want you to round to the 100th spot. For this one, I want you to round to the 1 spot. So on our activities today, when we're estimating a product is the answer of a multiplication problem. We're going to look to the greatest place value of each factor, okay? So we're going to be looking at the greatest place value in this factor, the greatest place value in this factor, and then it will give us a sort of new version of a number, something that is for sure easier to work with. So estimating is a good skill to have to sort of give yourself an idea of if your answer seems reasonable. And although this is just one lesson in your workbook, I hope that estimating is something that's constantly going on in the background of your mind while you look at a particular problem, okay? So right now we're just looking at our notebook where all of the times tables are, and you're going to help use that to sort of build up some of our fast facts, okay? For this first example, and I see $36.74 times 114, I'm going to call attention to the greatest place value in each of those numbers. So for this number, 3674, in order to round it, I'm going to just look to the digit next door, right? Do you remember when we drew the arrows to the digit next door? And we would say, would that digit next door, who's super bossy, would he make the 3 go up or stay the same? What would happen to the 3? It would go up, right? Because 5 or more, let it soar. 4 or less, let it rest. So that $36.74 actually becomes just $40. 40.00, or you could just write it as 40. 114, look at the digit next door, causes 114 to go to 100 or 200, guys? 100, because this digit next door isn't strong enough to shove it to the next place position, the digit. So we end up with 100. Now this is a tie from last week's assignment. We look for the fast fact, right? What's the fast fact? 4 times 1. 4 times 1 is 4. But then we call attention to how many powers of 10, 1, 2, 3 powers of 10 are going to build up that number. So we put that many zeros on the back of that product. Do you remember doing this? I remember that. So you can see they wrote it in a little bit different of arrangement. They wrote it horizontally and I wrote it vertically, but we have the same result, okay? Another skill that we're going to be working on today is adding a cluster of numbers that have similar values. So instead of adding 501 plus 498 plus 510 plus 508 plus 485 plus 493, your brain should go, wait a minute, those are all close to what number? What would be an easy number to round them all to? 500, right? You would say that's close to 500. Those are all close to 500. So instead of adding them all up, why don't I multiply them times how many 500s I have? And remember, this is just estimating. So this isn't finding the exact answer. But if you need to get like a good, reasonable guess, you would say I have 1 500, 2, 3, 4, 5, 6 500s. It's kind of like saying 500 times 6, right? And here's your fast fact. 5 times 6. What's 5 times 6? 30. How many additional powers of 10 are on the back of that number? 2 additional. So I have about 3,000 if I added those up all together. So the 2 skills we're going to work on today, all the crunching and wrappers in here with all the snack time going on. Can you guys hear all that clatter? We're going to work on 2 skills today. Estimating products using the greatest place value, and then adding clusters of numbers by using a related multiplication fact. Got it? Okay. Now, slide your notebook next to you. We're not writing in our workbook at all because I'm giving instruction while we work. That's why it's called guided practice. This is the part of the class where I have to, as a teacher, support your learning and give you tips along the way so I can build on them later on. So although you could probably figure it out, don't go ahead of me. Let's open to page 35 in our workbook and have those writing tools on hand. 35 in our workbook right now. 35. I'm going to pull it up on my screen here. And all my 5th graders at home, I have my AirPods in today. So if there's ever a spot where you can't understand what I'm saying or you have a question, feel free to chime in. Only me and the people in the Zoom call with you can hear, but maybe a question you have would apply also to the people here in the room. That might be helpful, okay? So on this first band of exercises, I kind of want to skip down to something more simple. So I want to look at numbers 11 through 13 first. I like the way that they have no decimals in them. They are just whole numbers. We're going to do 11 through 13 first. So when I look at these two factors, I want to underline the greatest place value that they each have. What's the greatest place value in 92? Is it the 9 or the 2? It's a 9. Underline the 9. How about in 21? What's the greatest place value? The 2. Okay. Now we're going to use that to go round. Would the 2 next door cause the 9 to go to 90 or 100, the next group of 10? Which one? 90, right? So underneath this, please write 90 times. And what would 21 round to? 20 or 30? 20. Good. So now we have 90 times 20. Do you see the fast fact in there? It's 9 times 2. So if you need 9 times 2, I see people going straight to their times tables chart. That's good. 9 times 2 equals what? 18. How many powers of 10 do you see? I see 2 powers of 10. One here, one here. Now, in the last lesson, we were highlighting those extra powers of 10 and then popping them on the back. If you still feel like that helps you and to a point where it helps you achieve the right answer, then still do it. That's a strategy. But if you feel like you are comfortable recognizing the powers of 10 without highlighting them, don't highlight them then. Your call. So 1,800 is the estimate, or 1,800 for this product. Let's look next door. Underline the greatest place value. That's a 9 and a 5. What would 91 round to, class? 90. And what would 51 round to? 50. Okay, what's the fast fact? 9 times 5. What's 9 times 5? 45. And how many zeros, how many powers of 10? One there, one there. 2 additional powers of 10 on the back, which caused it to be 4,500. Good. 13. What's the largest place value on this factor? The hundreds place. And the largest one on this number is the tens place. So remember, when you're rounding a 3-digit number, you only look at the digit next door. So you don't even care about that 6 at all. All you're caring about is, does the 8 cause the 1 to soar, or does it stay the same? It causes that 1 to go up a digit. What's the next digit after 1? 2. So that changes to a 2, and the rest change to zeros. Meaning 186 is closer to 200 than 100. And that makes logical sense, right? Yeah, what would 45 round to?
It's more.
45 would soar to 50. You got it. Yes.
You're breaking up on my end.
Yeah, you're frozen and I see a black screen.
And I can't hear
You're cutting in and out a lot.
You're breaking. Really hard to hear you.
Yeah.
Yeah, it is.
I'm looking at, I have a 100% signal here. And my AirPods are fully charged. My recording is still going. I'm not sure there's anything I can change from my end.
Everything.
I'm sorry, I didn't hear what you said, Aubrey.
It shows at the bottom of your screen like a little thingy, and it says that you have low internet connection.
Okay, mine is showing 100%. Is that maybe yours that's showing a unstable internet connection?
None of us can hear it.
None of us.
I can't hear you. Yeah, I can't.
Okay, guys. Well, I'm recording this lesson right now, and I'm hoping the recording is going to be a better quality than I think you're getting right now via the internet. I'm really feeling bad that there's nothing I can do from my side at this point in time. How about I keep teaching and hopefully that connection improves. And if not, then maybe just in about 20 minutes here when I'm done giving the instruction, I'll very quickly download the video and upload it to Google so that I'm not keeping you very much longer for instruction, okay? So I'm hoping that you could hear me describe what I'm planning to do here, okay?
There we are.
So here comes my fast fact. It's 2 times 5, right? And 2 times 5 is 10, right? And how many powers of 10 are adding on to this value? 3 additional powers of 10. So that changes it to 10,000.
Miss
Now
Moore.
that we've done a couple up on the top here, we're going to go and perform the same skill where we are underlining the greatest place value. We're going to write the rounded version next door. What would 29 rounded to the greatest place value be, class? It'd be 30. And what would 32 rounded to the greatest place value be? 30. Yes, Leah? If you're confident that you're performing that without making an error, then you don't have to underline it. This is a strategy I'm supporting you with. Okay, so now we've kind of changed this problem to be 30 times 30. What's 3 times 3?
Miss Moore.
And then how many powers of 10? 2 additional powers of 10. Okay. Go ahead and try rounding number 2 next door to it, and then we will follow the rounding directions in a moment here. I'm working here now. We've got 60 and 20, right? And what would our fast fact be? 6 times 2, which is 12, and add 2 powers of 10 to the back. Good. Next one, greatest place value is the hundreds position. So that would change this 215 into just 200. What would the 68 change into? 70. Fast fact, class? 14,000. Why do I have 3 zeros? Bristol, why do I have 3 zeros?
Miss Moore.
3 powers of 10 in the factors. Yeah, go ahead. We are not on the decimals yet. I will show you that process in just a moment. Let's finish these two, okay?
Miss
So
Moore.
greatest place value, 800, greatest place value, that'd be a 10. What's 8 times 1? Just 8. How many powers of 10? A 1, a 2, a 3? Got it? How about this guy? We've got two numbers that have hundreds digits. What would 305 round to? 300. I'm going to write mine up here. Times 285, what would that round to? 300 again. So I have 300 times 300. 3 times 3, 9. And oh my goodness, I have boop, 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 4 powers of 10. 90,000. Oh boy. Now here's the thing that is kind of 6th grade material coming at you right now. When we round with things that have decimal zones on them, we have to pay attention to how many decimal zones that factor has. So it's a little bit related to counting zeros, but we have to pay attention to where are those zeros located, in the decimal zone or in the whole number zone, okay? So let's round this like regular. $6 would, 6 is the greatest place value. So would that go from to $6 or $7? 6 or 7? Why 6? The 1 is being bossy to the 6, right? And telling it what to do. So it would just be 6.00 times 4. We're going to put 4 for now. So if it's a single digit, you can't round it down to 0, then you'd still get 0, right? When you are rounding to $6, you'll know that the result's going to be 24, but how many zeros are on the back of here? 2, right? So we're going to put the 2, but I want you to call attention to these 2 are in a decimal zone. So these back 2 also have to be in a decimal zone. So I'm going to swing that decimal point in. So now it's 24.00. $6 4 times is $24. Does that make sense? So however many decimal zones you have to make sure the decimal point goes in to your product that many powers of 10. So it's kind of now like you're keeping track of whole number powers of 10 and decimal powers of 10 at the same time, and figuring out which zeros belong to the whole number side and which zeros belong to the decimal side of things, okay? Let's look at number 7 now. Number 7, here's the whole number, the greatest whole number. What would $8.97 round to? Would it round to 8 or 9? $9. So let's put 9.00. And what would 42 round to? 40, right? So what fast fact do you see? 9 times 4, which is, look at your chart if you don't know, 36. And count how many powers of 10 do you see? 1, 2, 3. So put your 3 zeros. But now we're going to call attention to how many of those zeros are in a decimal zone. 2 of them. So highlight the back 2. It always has to be the back ones. And put your decimal point in between the decimal zone and the whole number zone. Yes, $360. Okay, for number 8, underline the greatest place value, $2 and $7.71. What would $2.25 round to? Go ahead. $2, thank you. So put 2.00. And what would 71 round to? 70. Fast fact, class. Can you find the fast fact? 2 times 7, 14. How many zeros? 3. But how many of those zeros are in a decimal zone? 2. So those last 2 have to be behind the decimal point. 140. Now, all of these, I guess we should have put this to begin with. All of these have a dollar sign in front of them because they are related to using money. So maybe go back and put that units symbol there, dollar signs. We have 2 more here. How you doing? Okay. Here we go. Underline the greatest place value for each. Would 1285 round to 10 or 20? Think before you guys answer. Think. Why 10? Bristol, what? Nope. If there's 2 numbers, you go to the greatest, all the way to the left. Greatest place value. When you're rounding, you go to the number next door, always. Remember we drew a little arrow when we were learning rounding? Remember, we would put an arrow to the guy next door. So if you still like to do that, you're welcome to. That goes to $10. What does 81 round to? 80 or 90? 80. Fast fact is 1 times 8? 8. Then we've got 0, 0, 0, 0. Oh my goodness. But how many of those zeros are decimal zeros? 2 of them. Put the decimal point in between your whole numbers and your decimal numbers. So that should be $800. How many zeros, Trevor? 1, 2, 3, 4 zeros, but 2 of them are decimal zeros. Okay, and 2 of them are whole number zeros. You were doing 10 times 8, I think, which you can do. 10 times 8 is 80. 1 extra whole number zero, 2 decimal zeros. How does 2896 round? What does it round to? 30. 30 times 20. Wow, I'm running out of room here. 30 times 20. That's a 6. And how many zeros? 4 zeros. How many are decimals? 2. So I smash it in between. That's $600. Okay, so for 14, 15, 16, guys, you're going to scan through those add-ins and say, if I were rounding these, would they be closer to 80 or 90? Which would they be closer to? 90. They would be closer to 90 as a group, right? 88 would round to 90. 91 would round to 90. 92 would round to 90. 86 would round to 90, right? How many of these do I have? 6. So then it's like saying 90 times 6, right? What is 9 times 6? Check your chart if you need to. 54. How many additional powers of 10? 1. Are they decimal ones or just regular whole numbers? Whole numbers. That's the estimate. That's the answer. Yes. But adding is different than multiplying. If you did 90 plus 90 plus 90 plus 90 plus 90 plus 90, you would get, think about 90 is close to 100, right? If you had 6 of those, it'd be close to 600. only if those were multiplying factors. When you're adding, you're kind of bundling them up. 10, 20, 30, 40, 50. You're bundling those groups of 10, those zeros. Once you have 10, then you can make another bundle of 100. So adding is different than multiplying. When we count powers of 10, we're only doing that when we're performing multiplication or division, those two operations. When you are doing add-ins, you're basically skip counting. You're going 90, 180, 270, and you're going down and down and down the chart. Let's see. Scan through these numbers on number 15. Look at their greatest place value. 300, 200, 200, 300, 300, 200. Round them to their greatest place value. Are they closer to 200 or 300? Take a look. What would 310 round to? 300. What would 287 round to? 300. 300. 300. How many 300s? 6. So we could go 300 plus 300 plus 300 plus 300. That seems like really long. Or could we just simplify it and do 300 times 6? That's the same result, right? Multiplying is repetitive addition. What is 300 times 6? Well, we go 3 times 6, 18, 2 additional powers of 10 on the back. Last one, 16. We're looking at these numbers and deciding, well, would I round to $5 or $6? Scan through them, $5 or $6. $6, how many times? $6 7 times. What would 6 times 7 be? 42. How many zeros on the back? 2, and they are both in decimal zones, right? So I'm just going to put my decimal point before I put those powers of 10 on the page. $42 bills. That's a lot of dollars. Okay, so I'm going to scoot. I'm going to scoot to your homework page, and I'm going to do some of the problem solving with you first. So everyone is going to look at the problem solving pieces with me. And then I'll let you go back and work on the top half, okay? But let's do some of 36 together here on the more difficult problems, okay? The rest will be homework, yeah.
This is more.
Yes?
Your screen's blurry.
I'm trying to fix that right now.
Okay.
Thank you. I'm not sure why it did that. Come on, little guy. Come on. There we go. Maybe my video camera needs some glasses. There, is that better, Tegan? It's a little better. Maybe because I changed the page, it needed a minute to focus. So we're on workbook 36 right now. And I'm going to walk you through some of the problem solving and set it up for you a little bit, okay? So let's read number 14 together. A school is purchasing 8 laptop computers. 5 laptops will be the less expensive model. And then it looks like, well, if there's 8 in total, 5 will be the less expensive one, which is right here. And the other 3, so we're going to get 5 of this one. And the other 3, because 5 plus 3 is 8, right? The other 3 will be the more expensive model. How much will they cost altogether? So if I had 5 of these, I'd be going 495 plus 495 plus 495, right? How many times do I have to do this? 5 times. but then I'm going to add the 3 that are more expensive, plus 510, plus 510, plus 510. But I bet you're noticing that each of those numbers, 495 and 510, are rounded to what value, guys? 500. So instead of doing all of this, your brain should go, you know what? This is more reasonable. 500 times 8. Isn't that more reasonable? So what is 500 times 8? You look to the greatest digit there and find your fast fact. What's your fast fact? 5 times 8, which is 40. Okay. And then how many additional powers of 10? 2 additional powers of 10, which means altogether I would have spent $4,000 on that equipment. No, not for 2. How many did we purchase? 8. It's actually a pretty good deal. Not saying it's easy to make that kind of money to buy a laptop, but yeah, go ask Mr. Courage how many iPads and MacBooks and all these things that we've bought to help with some of the tech side of things, including these cameras. But let's look at the next one here. Han needs to buy 189 calculators for science camp. Each calculator costs $28. Wait a minute. Do you remember what that word each means? It's on your math words paper where there's a plus sign and a minus sign and a multiplication sign and a division sign. Where does the word each fall? What operation? Each. And if it's not written there, we're going to write it. Write it in the multiplication bubble. If it's not in there, each. 189 calculators, and they were $28 each. Yes. Write it in the multiplication bubble. Each is a multiplication word. E-A-C-H. Say that again. Oh my goodness. Oh, it's up here. Oh, you're writing on the wrong page, silly. There you go. All right, so I'm getting back to the problem. I'm estimating 189 by looking at its greatest place value. What's the greatest place value for 189? It's the 100 spot. So would it go to 100 or 200? 200. And what about this 28? It would go to 30. Fast fact, 2 times 3, 6. How many powers of 10? I see 3. 3 powers of 10. And so each calculator costs $28. She said it'll cost about $6,000. Is she reasonable? What's reasonable mean? It makes sense, right? Reasonable means it makes rational sense. It makes sense. So yes, and then this is for you to describe. Yes, because blah, 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 because it says explain. That's for you to do. Now this is the last one, and we're just going to think about it, and you're going to write about it. So let's think about it together. Ani estimates that the product of these two numbers, here's the estimate, right? She's asking if the estimate will be less than the actual, or will the estimate be more than the actual? What do you think? So these are the original numbers. These are the estimates. Will the actual answer, that means the real answer, will it be less than the actual or more than the actual, and why? What do you think? Tell me a little, Bristol, and then Flori. She said less. Why? Ooh, She said because you're rounding down. Talk to me, Flori. Anything else? She said both of these numbers get rounded down. Therefore, they're smaller than they actually are. So if you rounded down with both, then the estimate will be lower than the actual answer. If you rounded up for both, what do you think would happen? The estimate would be higher or greater than the actual. If one rounded down and one rounded up, it'll probably be really close to the actual answer. All right, that's all of the instruction part I have for you. You're going to go back to the top and work on independent practice. Underline the greatest digit to help you round. Feel free to write it next door so that you can just see a fresh estimate problem. Okay? And finish off these couple of problem solvings with your explanation and words, okay? All right, kiddos, I'm gonna stop the recording right now and I'll download it real quick, upload it to YouTube, copy it over to Google so that if there were any parts that broke out for you at home, you'll be able to revisit those pieces of my instruction there, okay? I'll see you next time.